Hello guys, now we're gonna start solving parallel circuits. For that we're gonna construct one circuit with one battery, one switch, and now we have to use two light bulbs, but instead of using them in series we're gonna place them in parallel. That means that when the current leaves the switch, let's see, we can connect this here. Right? When the current leaves the switch, part of the current will go through one of the light bulbs, and the other amount of the current that is leaving the switch will go through the other light bulb. So let's see, we can close this. Now we can put this here, and now we have to close the circuit here. So a little bit more here. Alright, so let's see that now when the switch is off, it's open, nothing is flowing. If we close it, we can see that both light bulbs are shining, right? When we had one battery and two light bulbs in series, we couldn't see any light. There was some current, but the current was very low, so we couldn't see any light. And now we can see that with two light bulbs in parallel, we have we have some light, okay, that is being emitted by these light bulbs, okay. So now let's solve our table here, right? Let's see what's happening here. So first let's start with the current. If I place the cursor here, I see that some about 350, well, 349 milliamps are leaving this battery, okay. So we are going to our table here, our document, and we see that the current that is being generated by the battery is 350, let's say 350 milliamps. Alright, and now let's see what's going on with the current that is flowing through this light bulb. We see that this light bulb is getting 150 milliamps, and the light bulb below is getting the same amount of current, 175 milliamps. So let's go to our table and let's type that. So the current generated by the battery is 350, and then half of it will go through the bulb on top, and half of it will go through the bulb that is below, right? So we see now that when we have a parallel circuit, the current is being divided by the two components that are part of the circuit. Half of it will go this way, and half of it will go that way. Let's see what happens with the voltage. In order to see the voltage, we're going to place our cursor here. So we have 0 volts here and 1.5 volts here, as expected, because this is 1.5 battery. So we are generating 1.5 volts in this battery. And then let's see what's happening here. We have 1.5 volts here, and we have 0 volts here. So in a parallel circuit, both components are subjected to the same amount of voltage. Okay, so the current is divided, but the voltage is always the same. Right? So now let's complete our table. In our battery we are producing 1.5 volts. Okay, let's type that. So the voltage generated by the battery is 1.5 volts, and the voltage that is being consumed by lamp A and lamp B, let's check it again, it's going to be the same. Okay, after the light bulbs we have 0 volts, here we have 0 volts, and after light bulb B we have 0 volts, and before these light bulbs we have 1.5 volts. Okay, so this voltage is not shared. Okay, so the voltage is applied to this light bulb, the voltage of the battery is applied to the light bulb on top, and to the light bulb that is below that one. Okay, the one that is at the bottom. Okay, so let's type that. Now we have 1.5 volts here and 1.5 volts over here. And we are done. You can see that when we have two light bulbs in parallel, the results are very different than when we had these light bulbs in series. You can check it in your table here. With two light bulbs in series, the current was much lower, and the voltage that these light bulbs were subjected to were lower, because the voltage was divided in these light bulbs. In this case, the voltage is not divided. We apply the same voltage to every light bulb. Okay, guys, I hope this helps. See you in class.